Good afternoon, everyone, and welcome to our introductory lesson working towards a unit goal of not only a model and design of a F1 design car, but also a manufacturing documentation agenda, as well as an eventual website creation. What we're going to start off with on this particular unit goal with objective 5.0 is hit some extension items of 5.0 with respect to assembly drawings, detailed drawings, parts list, and balloon parts list at that on the assembly drawing. Now, this is something that we've been exposed to previously with respect to the AutoCAD environment and having created detailed drawings and assemblies in a 2D environment. Now, for the first time, we're going to be introducing it in a 3D environment. And a little bit later, what I'm going to ask of Nabil and Brent and Nikki and Hayden is, just how you've come to realize or appreciate the development in your earlier lessons in Sketch and AutoCAD that provided you an opportunity to make your way into this arena with respect to Inventor. Up until now, again, you've had your intro to Inventor lesson, and with that, a couple of tutorials that kind of got your feet wet with Inventor. But what we're going to do today is actually cover some material that speaks to the assembly piece, and that's going to be something that, of course, applies to your eventual F1 design car. Right now, you're all working at various stages with respect to your sketch work on this project, but we're going to work today with Inventor. So what you see on your screen right now is a cylinder rod assembly, and it's just an example file of a rod sticking through a rod support. It's a similar type inspection fixture that you might see in a quality inspection department. And what I'm going to do now is introduce you to this project before I get into Inventor from a PDF standpoint. So when we first created this file in Inventor, we were able to export it as PDFs. And as you can see with this file, this is the detail rod support that I'm going to start off with first, or CMP001. We always name our files that are supporting an assembly as CMPs. We always name our assemblies as ASSYs, as you'll see in a moment. If we were to have a sub-assembly that would make up the entirety of a complete assembly, we would call those SUBs. And you may very well encounter that in your F1 design car. So if you'll notice, these views were generated front, right, top, just as you would typically see in a 3-view layout in AutoCAD. But note the isometric view is provided here, as well as the title block information on the cylinder rod support. The other item that mates with this particular rod support is, of course, the pin here that's identified by CMP-002. You'll notice again, dimension, title block, that is complete with a drawing number, size, and title. Last but not least, you have the cylinder rod assembly, which again serves as yet another great sample file, reference file, if you will, that shows a sample parts list of what we're after with the Formula One design car, with both items that are listed in the BOM here to their quantity of 1 and identified as items 1 and 2 along with their descriptions. You'll notice that you've got that conventional 3-view layout as well as an isometric view, only the difference is now you see balloons as well as dimensions that indicate the item numbers that make up this assembly. And again, it's an ASSY category as opposed to a CMP because it is in fact an assembly drawing. So this is just a real basic fundamental look at detailed components and assemblies, and it's imperative that you understand it moving forward with this section on assemblies and components. So I'm going to back out of the PDF format for a moment, and I'm going to go into the cylinder rod that supports this assembly, if you will. The cylinder rod, and I'm going to also go back to the assembly and open up the cylinder rod support. Notice that, and this is well within your wheelhouse, what we're talking about here is nothing more than a sketch of a horseshoe effect, and with that we performed an extrude of 1.5 inches, right? Very basic stuff. Now the difference is, of course, you've got holes in them, and these are Boolean operations that were performed after the fact. Lastly, we had a chamfer 1 and 2 that just allows ease of passage through from one end to the other, starting that pin through the 2 holes. If you look at the rod, it's nothing more than a sketch of a circle, as a matter of fact, that's extended. I think it's extended as part of an extrusion. If I edit the feature, yeah, symmetrically 5 inches total, 2.5 in each direction, right? Very basic. Now, Nabil and Brent, can you tell me if you had encountered any issues with your mating components coming into your assembly? Yes, exactly. That's a typical problem that you're going to run into where it pertains to constraints. Sometimes constraints can be tricky because you don't know whether or not you want to mate to two surfaces coming together or to an axial alignment. And what I'm going to show you is just that now. So again, the individual components are straightforward enough, and you've had some modeling experience to where you're comfortable with that. Now we're going to really delve into the assembly. So what I'm going to do is I'm going to go ahead and remove both the cylinder rod and the cylinder rod support by basically just deleting them and starting anew. Now, the way you start out is you go to assembly and you place. In placing a component, you are in effect pulling from your file structure a file that will start you off on your assembly. And in our case, we're going to go to reference files and we're going to pull the rod support, because we would need the rod support. It'd be easier to pass the pin through the rod support than vice versa. So I add that in and I just place it. Right now, I'm not concerned, and that's just a button click, and an OK. I'm not concerned with where this is relative to X, Y, Z, 0. I just want to get it into space. And it's not an assembly, of course, until we add at least one more item. And how many more items do we have as part of this assembly? Just one. So I'm going to bring in another component. And there's a couple of different ways you can do this. We're going to just right-click in the screen and we're going to call out the rod. And now, how do I mate it? First, I'm going to just place it on the screen and hit OK. And then I'm going to do a constrain with the axis of this guy and the axis of that guy and hit OK. You're not done though, are you? Because ideally, you want to have two constraints in order to fully constrain this object. You want the one that's axial, and then you want the other that's flushing the face out. So what I'm going to do next is I'm going to go from here to here. Actually, wrong way, cancel. I'm going to go constrain, and then I'm going to do, actually, I'm going to do, let's see, a flush. I'm going to go this surface to this surface and then apply it. Okay, so now you have a fully constrained cylinder within the 2-hole alignment of the adjuster and flush to the back face. Later, you can see why the chamfers are there. They'll provide a groove, a beveled groove for sake of the weld. And that's how you go about creating an assembly, real basic assembly, albeit, but an assembly in Inventor. Secondly, from here, what I can do is I can create a drawing. You saw the PDF of our cylinder rod assembly earlier, actually right here, I had it in the first place. This drawing, this model or assembly, I should say, can easily be generated in the form of an assembly. You go to the big I, the new assembly, and we're going to just create this from scratch too. And once that comes up, provided it comes up, there we go, we're going to go ahead and place new drawing. There we go. We're going to go ahead and place our views. Place views is the first and foremost thing we need to do. And we're going to go with the assembly view 1, 2, 3, okay. And of course I can change the scale and so forth and change the sheet just to get to this, but I wanted to show you outright how you would label this and add a auxiliary view. Actually, if I add a projected view from any one of these views, I can just pop in the view like that and create. Again, you could reduce the sheet size, or you could expand on the view size. It would be up to you. Right now, we're just wanting to max out on our real estate, and that's the agenda typically. I'm going to go ahead and leave it alone for now, just for the sake of introducing you to the next item, and that is to add your parts list. So you go to the Annotate tab, you hit Parts List, and you make sure you're hitting on your assembly, left direction, structured, okay, and you can pop it right down here, and it should snap in place. And you'll notice the two items are there, just like they were on our PDF. I could have reference dimensions that are basically in parentheses showing the height and the width and the length, for that matter, of what's already on the mating components that were manufactured independent of one another. But for the here and the now, I just want to show you the BOM, and then notice that if I go to balloon it, really easily, it automatically knows which is which. That's pretty much all I wanted to get into today. We can expand on this further as we develop our product in so far as the F1 Formula 1 car design is concerned. Just wanted to gain you an understanding of how this works. And of course, we'll be working with you independently or as in your teams to solidify this information. Nikki and Hayden, I know you're still in the sketch phase, and that's great. Your sketch design looks fantastic. Now, that coupled with your information that you have here with respect to your prior learning on top of that, in Inventor and in AutoCAD, you should have enough of a basis to go on in order to move forward with this design project. Any questions at this time? Nope. Well, I will see you immediately following this recording, and we'll pick it up from there. Thank you.